Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And it's called There's a Lady Sure, All That Glitters is Gold, and she's buying a stairway to Sudoku Heaven. And it's by Doc Logic. I don't know why I wanted to do that. I just wanted to do that. Anyways, here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or designated 9-cell regions, which are boxes in this case. We also have arrows, where digits on an arrow sum to the digit in the attached circle. So for example, actually, all of these digits, these 2 digits must add up to what that digit is, these 3 digits must add up to what that digit is, these 3 digits must add up to what that digit is, etc., etc. Same with this. These 2 digits must sum up to what that digit is, these 3 digits must sum up to what this digit is, and etc., etc. And for example, if this were, say, 2 and this were 4, this would have to be a 6 to add up with to these 2 digits. We also have German whisper lines, where digits along each green line have a difference of at least 5 to their neighbors. So for example, if this were a 7, this would have to be a 1 or a 2, because the only digits which are 5 or more away from 7 are 1 and 2. And that's how German whisper lines work. We have Renban too, where digits on a purple line form a group of consecutive digits in any order. It actually looks more pinkish to me here, but I don't know. Maybe that's just the color there. So for on a Renban line, they form a group of consecutive digits in any order, and you don't have anything about repeats because they are all in the same row. So as an example, you could have something like 7, 6, and 8, and those are all consecutive. They all form one consecutive group, 6, 7, and 8. You could not have something like 5, 7, 8 because there's a gap between 5 and 7, and that's not consecutive. And that's how Renbans work. And finally, we have Kropke dots, where cells linked with a black dot have a ratio of 1 to 2. Cells linked with a white dot are consecutive, and not all possible dots are given. So, for example, if this were 2, this would have to be 1 or 4 to maintain the 1 to 2 ratio. If this were, say, let's say this was 6, this has to be 5 or 7 to make sure that these digits are consecutive. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. So this is the sum of 3 unique digits. Actually, how many digits are less than it? This must be less, this must be less, this must be less, this must be less, and these 2 must be less. So this is 7, 8, or 9 because it has at least 6 digits which must add up to it with another digit. So this one similarly has 1, 2, 3, 4, 5, 6. And this must be, so this is, well, we don't know actually. It has 1, 2, 3, 4, 5, 6 digits less than it. So this is 7, 8, or 9 here too. This digit is in a 1 to 2 ratio with 2 other digits. The only digits that can fulfill that are 2 and 4. So if it's 2, it has to be next to, if this is 2, that means it would have to, this cannot be 1 because 1 is only consecutive with 2, and we already have a 2 there. So this would be 1 here, and this would be 4, which could be consecutive with 3 or 5. If this is 4, this could be 2 or 8, and this could be consecutive. 2 can be consecutive with 1 or 3. 8 can be consecutive with 7 or 9. Or this could be 8 here, or 2. So we know in row 9, one of these has to be 2 and the other one has to be 4. Actually, in fact, this has to be a 4 here. Guaranteed. Because you cannot have 4, 2, 1 here. So this is 2 and 4, which means that eliminates 1, 2. It eliminates 2, 3, 3, 4, and 4, 5. So this could be 5 through 9 here. But this digit is smaller than this, and it sums up with 2 other digits to add up to that digit. So this is at most 5, 6, or 7, which means this can't be 5, 6, or 7 here. Let's see. Um, 5 can never be here. These digits must be 1 through 6. This is at least 5, so these add up to at most 4. So that means it's 1, 2, or 3 here. 2 cannot be here, though. This is 1, 2, or 3, which is consecutive with 1, 2, 3, or 4. Hmm. This is at least 1 and 2 here. So this must be 6 at most here. This could be 1, so this could be add up to 8. So it's at 1 through 7 here. This is 1 and 2 at most, or at least. So this has to be 1 through 6. This could be 1 through 7 then. That means this is 1 through 8. This is also 1 through 8. Add it up. So 9 in this box must be either here or here. Because this cannot be 9. These digits are in a 1 to 2 ratio. These digits are consecutive. This is at most 6 because this at least adds up to 3 at least. This is 1 through 7, but this can't be 5 or 7. Oh, that's interesting. If these are 2 lows here, that means this is high. These are both low. So the rest would have to be high then, if that's the case. So this would be 5 or 6. This would be 5, 6, or 7. That doesn't really tell us much. This is a 1 to 2 ratio. So what? Okay, this is 1, 2, 3, 4, 6, 8. These are 1, 2, 3, 4, 6, 8, but obviously this can't be 4 or 6 because it's consecutive with 2 unique digits. And 4 and 6 can only be next to 1 unique digit on a German whisper line. So if this is low, sorry, if this is 8, it has to be next to 2 lows. This is then 4. So if this is 8, this is 4. this has to be next to two lows, so it's 1, 2, 3, 1, 2, 3. If this is 1, this is 3, this has to be 6, and this has to be 8, 9, and 8, 9. If it's 2, it could be 4. It cannot be 1. If this were 1, this would be 2, but 1 can only be consecutive with 1, 2, or 3. So if this is 2, this is 4, and it has to be next to 7, 8, 9. If it's 3, it's obviously 8, 9. So if it's 8 or 2, it has to be next to 4. If it's 1, it has to be next to 2, which means this could be 6, 7, 8, 9. So these are the possibilities for these cells. These 3 digits are consecutive. These 2 digits are consecutive. Okay. If this is 4, 5, or 6, that means this adds up to 5 at most. So if this is 4, 5, 6, this adds up to 5 at most here, which means this is a 1, 2, 3, 4 triplet or quadruplet, which forces this to be 8, this is 4, this is 2. That would make this 1. Okay, so if this had 2 low digits here, that means these are low. We know for certain because this is only 1, 2, or 3, because this is 5, 6, or 7 added together, because 2 and 4 are here. That eliminates 1, 2, 2, 3, 3, 4, and 4, 5. So it could be 5, 6, 6, 7, 7, 8, or 8, 9 to be consecutive. That means this is 1 and 3 at most, added together with the 5. So if this is 2 lows here, that would make these 4 lows, and the rest could not be low. So this would be 5 or 6, which means, again, this must add up to, at most, 5. Or actually, it would add up to at most 4 for these 2 digits, which means it's less than 5, 6, or 7. So these would be from 1 through 4. These 4 cells would be from 1 through 4, which would force this to be 8. That makes this 4, which makes that 2, which makes that 1. But that's 3 low digits when we said we already had 2 low digits here. So this cannot be 2 lows here. This must be a low, and these must be highs here. Therefore, this is 1, 2, or 3 here. It must be next to 6, 7, 8, 9 here. 4 cannot be here. That's interesting. This can never be 7 and 8. If this is 7, 8, that forces this to be a 5, 6 pair, which eliminates 7. 7, 8 eliminates this as this has to be 9. This is 5, 6, this is 7 or 8, which would force these to be 1 through 4. But the problem is we have 4 digits here that are 1 through 4, which is not allowed. So this cannot be 7 and 8 here. This could still be 7, but this can't be 8 here. This cannot be 6 and 7, because that would force us to be a 5, 8 pair, which is not consecutive. So this can't be 6, 7. Can it be 5, 6? If this is 5, 6, you have the same problem. If this is 5, 6, this is 7, 8, which forces this to be 9. That leaves these digits as 1 through 4, but we have 5 digits that are 1 through 4 there, and if that's the case. So this cannot be 6. It could be 5. This could be 4, 5. Does work, because this could be 6, 7. No. If this is 4, 5, I guess this could be 7, 8, and this could be 6. So that's possible. Huh. These digits are consecutive. If this is 1, 2, that forces this to be 3, 4. At least. Well, you could have 2, 3, 4, 5. This could be high. Can this be high and high is kind of the question. I guess you could, right? Oh, this is interesting. Okay, so this is at least 5. So this adds up to a 4 at most. One of these must be a 1, and they both see this cell, so this can never be 1. Therefore, this is 2 or 8. This has to be 4 next to the 2 or 8, because that's only the only digits from a 1 to 2 ratio. So this can't be 4 here. This is 4. These can't be 4 at all. So no 4, no 4, which means this can't be 8. It couldn't be 8 anyways. This can't be 4. This can't be 4. This is 1, 3, 7, 9 here. So this can never be 8. That forces this to be 6 with either 5 or 7 here. That means 6 cannot be here. 6 cannot be here. That leaves in the rest of this box. There's no other place for 8 and 9 except for these two cells. So this has to be an 8, 9 pair. That means this cannot be 3 here. If this were 3, then this would be 8 and 9 here, and that would therefore have 3 digits, 3 cells in the row, which would require an 8 or a 9. So this is 1 or 2, which means this cannot be 1 here, because that would force this to be 2, and then this digit would not, this cell would not have a possible digit. So it can't be 1. 7 is either here, which makes this 6, 7. Or this is 7, which would mean this is 1 and 1. That's interesting. So if this is 7, okay, if this is 7, this is 6 and 7. That would mean these are from 1 through 5. We already have the digits 1, 2, 1, 2, 3, 4. Okay, so this can never have a 1 because if this is 1, that would be consecutive, and it would require a 2 to be next to it, and that would, again, remove all possibilities for that cell here. So this has to contain a 3 here, which means this cannot be 3 here, and it cannot be 3 here. So either this is 7, which forces this to be 1, 1, which is not possible because then this would be 3 and 2 at minimum, and that's not, so this has to be 1 here. So this is 1 here, which means this, because it cannot, it has to have a 1 here somehow, and you can't have 2, 1 here anymore, because that would eliminate all possibilities for that cell. So this is 1. It cannot be with 7 here, but we know this can't be 7 because that requires this to be 1 and 1 to add up to 9. So this can never be 7. We have a 1, 2, 3, 4, 5 quintuplet, which eliminates 1 through 5 in the rest of the row. This can't be 1 through 5. This has to be 6 through 9, which means this is consecutive with 6 through 9. So 4 cannot be here. 4 cannot be here. This is 5, 6, 7, 8, 9, which forces this to be 5, 6, 7, 8, 9. 9 cannot be here on this Ren band because that would force an 8 to be on the Ren band to be a consecutive set. So this is 6 and 7 here to add up to be on the Ren band. It's with 5 or 8. So this cannot be 6 or 7 here. This cannot be 5 and 6 because there's no place for the 7 anywhere else in the box. So this must be 6 and this must be 7 here. This is 6, 1, and 2 at minimum. And it has to be 2 to add up to 9. So this is 9, this is 8, which means this is a 5, 6, 7 triplet in this Ren band. That eliminates 2 and 5 here. This is a 1, 4 pair. This 2 means this has to be 3 here. There cannot be a 9 here, here, or here. So this has to be 1. This cannot be 1 or 2. This digit has to add up with 1, 4 to add up to 9. And so it's 1, 4, and 4 to add up to 9. So this is 4, this is 5. This has to be a 2, 3 pair here. So this is 2 and 3. 2 and 3 can only add up with 6 and 7 to add up to 9. And 5, 2, and 3 can add up with 1 or 2 to add up to 9. So either this is 2 and 2, and this is 3, or this is 3 and 1, and this is 2. So either way, 2 has to be one of these two digits here. This is in a 1 to 2 ratio, but it cannot have 4, 1, or 8, so that eliminates 1, 2, 2, 4, and 4, 8. That leaves only 3, 6 remaining as the digits in next to the black Kropke dot, which eliminates 3 and 6 in the rest of the column. So this can't be 6. This is 7. 7 and 2 add up to 9. That forces this to be 3, which makes this a 1. That leaves 9 here. This 2 eliminates 2 here, so this is 8, 4, and 2, which means it's next to 3 here. 5 has to be one of these two digits, so this cannot be 5 here. This can't be 8. This is a 6, 7 pair here, which forces this to be 5, 9. This can't be 8 anymore, so this can't be 6, so this can't be 3. Therefore, one of these is a 2. This can't be 1 because of this one, so this must be 2. That makes this 4. The 2 has to be next to 7, 8, or 9, but the 7 here eliminates 7 from the possibilities, so this is specifically then 8 and 9 that the 2 is next to. This can't be 1 or 2. This can't be 1 or 2. The remaining digits in column 4 are 1, 3, 5, and 9. 9 cannot be on the arrow part of an arrow. The remaining digits in column 7 are 2, 5, and 9. If this is 6, it would have to be next to a 1 on a German whisper line. So this can't be, and this can't be 1 because of this 1 here. So this is 3, which forces this to be 6. So this is 8 or 9 here, but it can't be 9. So this is 8, which makes it next to 1 or 2 on a German whisper line. So this is a 1, 2, 1, 2 pair, which eliminates 1 and 2 in the rest of the box. This 6 eliminates 6 here. This can't be 3 because of this 3. This can't be 8 because of the 8 in the row. If this is 9, it has to be with 8 and 7. And 8 can't be here, so this would be 8 and 7. If it's 5, it's 3, 4, 5, or it's 4, 5, 6, or 5, 6, 7. So if it's 3, 4, 5, this is 3, this is 4, and this is 5. If it's 5, it's 4, 5, 6, this is 4, this is 5, and this is 6. If it's a 5, 6, 7, it's 5, 6, and 7 here. Okay. 5 can never be on a German whisper line, so that can't be 5. 4 would have to have a 5 here, no matter what, because it can only be 3, 4, 5, 4, 5, 6 here. It can't be 2, 3, 4. So this can't be 5. This can't be 5. Therefore, we know we have a 2, 9, 2, 9 pair, which eliminates 2 and 9 from the rest of the column. So this is 5. This can't be 5 then. This can't be 5. You can have either 3, 4, 5, 4, 5, 6, or 5, 6, 7. So this can't be 8 here. This can be 3, 4, 5, or 6, 4, 5, 6. So 5 can't be here again. The rest of row 7 is 3, 4, 5, 6. Well, this can't be 3 or 5, so this is 4 or 6. This can't be 4 or 5, so this is 3 or 6. And then we have 3, 4, 5, 6 here. This can't be 3 because of that 3. So we have a 3, 5, 6 triplet, which eliminates 3, 5, and 6 from the rest of the box. This is 3, so this can't be... Whoa. This is 3, so this can't be 3. This has to be 6, which makes this 3, which makes this 5, and this 6. The 5 eliminates 5 here, so this is 9 and 5. This can't be 3. We know 7 is one of these two. If it's 7 here, this has to be 1 here. If this is 7 here, this has to be 1 here. Because 7 can only be next to 1 or 2, and 2 can't be here. So this must be 1, 7 pair, which eliminates 1 and 7 from the rest of the row. This can't be 1, so this is 9, which makes this not 9. So this is 2, this is 9. 2 can only be next to 7 on a German whisper line out of 1 and 7. So this is 7, this is 1. This 9 eliminates 9 here, so that's 8 and 9 here. This 3 eliminates 3 here. This can't be 6. This can't be 1 or 2. If this is 4, it would have to be in a 1-2 ratio with 8. That's fine. Or it could be 3, 6. So this is 4 or 6. This is 4 or 6. The rest of the box cannot contain 4 or 6. 9 is one of these two digits here. We have the remaining digits in this box 3 as 4, 7, and 9. So this is 4, 9. This is 4, 7, 9 here. 5 has to be in column 8 somewhere, but it can't be any of these digits because of the 5 in the box. Can't be here because they're filled out. Same here. This can't be 5 because of this 5. So this must be a 5 here, which leaves this as a 3, 4, 6, 8 pair here. This can't be 4 or 6, so this is 3 or 8. Since one of this is 3 or 8 and one of these is 3 or 8, this can never be 3 or 8, so it's a 4, 6 pair, which eliminates 4 and 6 from the rest of the column. So this can't be 4. This has to be 9. This can't be 9. That leaves this as an 8. And this is as a 3. Those are the only digits remaining left. This can't be 3. This is 1, 2, or 7 here. 1, 2, or 7. This can't be 1 or 2 because of the 1, 2 in the column. So that forces this to be 7. This is a 9 then, so this can't be 9. These can't be 7. This 3 eliminates 3 here. So this is 8. This cannot be 4 and 8. This is a 3, 6 pair, which eliminates 6 in the column, or sorry, 6 in the row and 6 in the box. That means this is 4, which forces this to be 6. This is 1 and 3. This 9 eliminates 9 here. This 1 eliminates 1 here. So this is 4, this is 1. 1 and 3 add up with 6 and 8 to add up to 9. This cannot be 1, 2, 6. It has to have a 3. This is either 1, 3, 5 or 2, 3, 4. So 3 has to be one of those 3. Remaining digits in column 6 are 4 and 8, but this can't be 8 here because of this 8, so this is 4. Actually, this 8 eliminates 8 here, so this is 6 and 3. This can no longer be 3 here, so 3 has to be one of these two digits, which means this can't be 3. This is 1 and 5 here, so that must be with 3, 1, and 5 to add up to 9, which means this can't be 1, 3, or 5 because of the 1, 3, 5 triplet in the row. So this is 2, this is 1. That 1 eliminates 1 here, so this is 5, this is 1. This has to be an 8. These can't be 1s here. This can't be 6. This can't be 6, so this is 3, which makes that a 6. This 3 eliminates 3 here, so this is 5 and 3. This can't be 5. This can't be 6, so this is 7, which makes this 6, which makes this 5, which makes that 4, which makes that a 5. 6 and 7 here means this has to be 8. This 6 eliminates 6 here, so it's 7, which makes that a 6. This is 1 and 2 adding together with 6 to add up to 9. You can't have 3, 6 here. You can't have 4, 5 here. You can't have 1, 8 because the 8 can't be here. So this must be 2 and 7. This can't be 2 because of that 2. So this is 7. This is 2, which makes this 1, and 2, which makes that 1. 2 has to be here remaining. This has to be 7, and this is 9. The 7 eliminates 7 here, so this is 4 and 7. And we have the remaining digits are 4 and 8. This is 4, this is 8. And that's how you solve it. Yeah, not too bad. I don't think this was really necessarily challenging. It's just basically a lot of elimination here, right? And just getting that break in was really key. But it wasn't that hard with this 2, 4 eliminated here, right? Yeah, I don't know. Seemed fairly straightforward, but maybe it's just something that, I don't know. Maybe it's just straightforward to me. Anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.